Okay, welcome back to our podcast series called Lime Time in Texas. I'm Dale Rand, the Executive Director of the Lime Association of Texas, and today we have a special guest, Kevin Ingram, who is what I would consider a real expert in the use of lime. So I'm going to have Kevin introduce himself and tell us a little bit about his background.
Well, just real quick, I have a PhD in chemistry from North Texas. It was more industrial, fly ash, cements, lime-based stuff. I've been in the lime industry for almost 32 years in R&D and technical service.
Okay, and we're doing this kind of as a four-part series on, interviews with Kevin, asking different questions, and we covered, the first podcast was on general use of lime. This time I'm going to go into very specific questions on the environmental uses of lime. So I'm going to just start off by asking Kevin the most common, if you can just talk about how lime is used in environmental applications, because we know that's a big use of lime throughout the United States.
Well, the biggest single customers in the U.S. are going to be flue gas treatment plants. So you're burning coal. Coal has some sulfur in there, just the way Mother Nature made it. Cysteine, methionine, or amino acids, they're part of the coal matrix. The sulfur doesn't leave. So you burn it. How do you get rid of it? Well, the easiest way is to have a scrubbing system. So there are wet scrubbers out there. You make a slurry of lime or limestone. They spray down, all that gas is going out, go through the water like a shower head, and all the acids dissolve into the water and then react with the lime. So you end up with calcium sulfite, calcium sulfate. That gets rid of a lot of acid rain. Now, let's take a step back. Acid rain, what's the problem there? A lot of young viewers won't remember in the 1970s, the Finger Lakes in upstate New York started getting pHs down in that 5.7, 5.5 range. At that point, fish die. That's not good. So they realized if you go into Pennsylvania, there's a lot of cement plants, there's a lot of power plants, there's lime plants. All their emissions were coming out, traveling, and then coming down as rain. So you had to start worrying about treating that to improve the environment. So there was limestone. It wasn't quite so efficient back in the original, but lime systems could be found to be 95 to 99% efficient at removing sulfur. So the number one use is going to be mass removal of sulfur. While we're talking about acid gas treatment though, we also have to worry about small facilities. Let's say a brick plant. Wait a minute, a brick plant puts out impurities? Well, you're using clay. Clay is sort of like activated carbon. It's nature's sponge. It likes to suck in all the impurities. So you're digging up a clay deposit. If there's chlorides or fluorides or heavy metals, they're going to tend to stay in that clay. Well, I'm making my bricks. I'm burning it. It's getting hot enough. I'm driving off those compounds into the stack. Well, geez, that's not good because hydrochloric acid, hydrofluoric acid aren't good for anyone. So what will they do? Well, they don't want to have a big scrubber because those liquid scrubbers can be hundreds of millions of dollars. So what do? You take a hydrated lime, calcium oxide been slaked to calcium hydroxide as a dry powder, and it's blown in the duct. It reacts while it's traveling, and then it gets caught on the baghouse. The baghouse is there to catch particulates. When you burn, stuff can come off. It gets on those bags. All the acid gases have to go through that alkaline material, and so you can trap. And so you can get 95% removal of chlorides and fluorides that way. And so it's rather important to have lime in those situations. Now, what's another use environmental? Water. We all like to drink water and not have issues with it. Well, what can lime do? Well, first off, a lot of people, not everyone has to use lime. I'll admit that. But where would you want to use it? Well, first off, if you're in an area that the water is going through limestone. Let's take Austin area. What's the problem with limestone? It's calcium carbonate. Water falls from the sky in rain. It's pretty pure. There's nothing in there. Water doesn't like to be pure. It wants to dissolve things. Limestone's going to dissolve. Plus, when water in the rain comes down, it's picking up CO2 from the atmosphere. That forms carbonic acid. pH 4.5. Limestone's pH 8.5, and whenever you have a difference in pH, you're going to get a reaction. So that carbonic acid helps to dissolve a little limestone in there. We all want a little in there because the taste is better in the water. But if you get too much, you get something called hard water. Now, it's not like you can tap on it or anything, but it's going to do things like not allow soaps and detergents to suds up. You don't want that. And so the easiest way to remove hardness is to add lime. So you may have lime hardness, calcium bicarbonate, but as an acid, you react with calcium hydroxide and you have an acid-base reaction and you get rid of the hardness. Oh, that's pretty good. What else can it do? Well, the next thing is metals removal. You get a lot of metals. You get iron, let's say, because the dirt has iron in it. That's why it's red around a lot of places. What's the problem with iron? You go to wash your clothes, all of a sudden your whites turn yellow. Now, back in the 50s, they would use bluing in their washer. Blue and yellow, whenever you're bouncing off, it makes white. You know, it's not yellow and blue make green like in the commercial, because that's seeing through. People don't want to put bluing in there. They want the fabric to stay how it is. So how do you remove iron? You raise the pH. So the water naturally, even if it's neutral in the 7 range, you raise the pH up closer to 10. And at that point, most all the metals will become insoluble. Yeah, there's going to be a part per million, part per billion in there, sure, but most of the metals will precipitate out. And no one really wants to be drinking iron. No one wants to be drinking cobalt. Out in West Texas, something called radium. Yeah, that's not good for you. So lime can remove a lot of heavy metals. Also, if you have phosphates or sulfates in your water, lime's going to react with those, precipitate out, and remove them. So that water and air, those are important. And those are the main environmental uses of lime.
What about, maybe this is not environmental, but the mining, I know you talked about, in the mining operations, lime's used quite a bit for that.
So it depends on where you're talking about. You can have something as simple as acid mine drainage. So let's go into the Northeast where you have a lot of old coal mines. The water's percolating through the ground, is coming up, iron's dissolving, arsenic is dissolving. That's bad. So lime or limestone can be used there, raise the pH up. When the iron precipitates out, the arsenic precipitates out. Yeah. If you're talking about something like phosphate mining, you end up with a lot of acid after it's over with. They try not to treat it, let evaporation happen, but occasionally they have to treat. The best thing to do is lime. It's a 2-stage operation. They'll raise it up to about pH 4, drop out some of the materials, and then raise it up to 8 to 11, depending upon what all they're trying to get out. So it's a way to get rid of acid mine drainage. It's a way to get rid of any acid and neutralize it.
Okay, what about back to the water, wastewater? On the wastewater side, I get questions sometimes about sludge remediation. So how is lime used in?
Well, there's a couple of things there. First off, it depends on what type of wastewater you have. Let's say you have an industrial plant and all your water is going to the local city. Well, if it's coming out acid, you're going to have to treat it before you send it to the city because you don't want the pipes to dissolve. So it can be used there in different industrial plants. So you can use lime added or help with odor control. So in a city, I won't say which ones in the US, they actually add lime into the storm sewers whenever they aren't getting a lot of rain, because you start getting hydrogen sulfide odors. Stinky eggs you don't like. Yeah. So you can put it there. But sludge, what is sludge? It's all the stuff you've dropped out. Human sludge, let's just go with that. It's a subject we all deal with daily. What do you do with that? Well, one thing you can do is once you filter it out, maybe add lime in there to help, or flocculate it, it settles out, you really want to treat it. So there's something called EPA 503 rules for reuse of human byproducts. It's a subject people don't like to talk about, but if you keep the pH above 11 for extended time, you're creating an environment detrimental to pathogen growth, and then it can be reused. You have to keep animals off of, or can't sell for 30 days, crops have to be 30 days on the ground. If you keep the temperature up long enough and the pH, all of a sudden it becomes Class A biosolids that can go into potting mixture immediately.
Okay, interesting. Yeah, I do get a number of calls sometimes and questions on our website about sludge remediation. So I think that's all the kind of the main questions I have, just some of the general uses environmental. I don't think a lot of people think in terms of lime being used in those applications. And we spent a lot of time in this podcast series talking about soil stabilization of clay soils. So I wanted to kind of let Kevin talk a little bit about how lime is used in these environmental applications. So as always, if you have questions for us, please submit those questions to Dale Rand at limetexas.org or just limetexas.org on our website, and we'll get those questions to Kevin or myself and try to follow up with you and answer any question you might have about the environmental uses of lime. And again, this is kind of a second part of a 4-part series where we're going to be asking Kevin questions. And as you can see, Kevin knows a lot about chemistry. He's the reason people like I got D+ or C- in chemistry, because there's always somebody busting the curve in chemistry. That would be this guy. So thank you for
Absolutely, Dale.
joining us, Kevin. Thank you for watching this episode of our podcast. If you want to learn more about the use of lime, reach out to us on our website at limetexas.org. You can also email me at dalerand@limetexas.org. And please follow us on LinkedIn and subscribe to our YouTube channel. Thank you for watching.